An interesting problem. Find the volume of the solid that lies between the planes perpendicular to the x-axis at x equals 1 and x equals 2. So here's x equals 1, here's x equals 2, and these are planes perpendicular to the x-axis, and whose cross-sections perpendicular to the x-axis are circles, like I have drawn in here. There's a sample disk, and whose diameter runs from the x-axis up to the curve y equals 2 divided by the square root of x. And I drew that in here. This blue line right here is y equals 2 divided by the square root of x. And so, an interesting problem. Okay, subdivide. First we'll subdivide into the circular disks, although they're not really disks because the side is somewhat slanted. Approximate each piece with a disk of radius 1 divided by the square root of x. Now that's interesting. Why do I say the radius of that disk is 1 divided by the square root of x? And the answer is from here to here we have 2 divided by the square root of x, and we want to know what's the radius of this, and that's half of 2 divided by the square root of x, which is of course 1 divided by the square root of x. So we can add up all the disks. By the way, if you approximate the volume of a disk, it's probably pretty easy to see. One disk is pi times square root of ci squared, where ci is some point in the side of that disk here on the x-axis. And so this would be the square of that. Technically, I guess I should have squared the 1 too, because you square the radius, and the radius is 1 over the square root of x. So I guess it would have been a little bit more technically correct to write it like that, but I don't think it's going to matter much. There's the thickness of the disk, and so the limit, of course, is going to be as the maximum of those goes to 0, the same expression, that sum. But now when we see that sum, we say, well, if pi factors out, this is just going to give us 1 over the square root of x squared, which is 1 over x. So in other words, identify this integral in there, and that's not terribly hard to do. Integrating this, we get ln of x, so we get pi times ln of x, x going from 1 to 2, so pi times ln of 2 minus ln of 1. Of course, ln of 1 you should know is 0, so it's pi times the ln of 2 would be the volume of that unusual shaped object by slicing.